welcome everybody to the Tom and Lonnie Chat. I'm Dr. Tom Purpose over at Georgia Tech, and we've got Dr. Lonnie Love. Hey, Lonnie, from Sandia National Laboratory.
Great seeing you, Tom. Happy holidays.
Thank you. Happy holidays to you as well. In fact, I got all dressed up for you just to sort of show you. I got my special tie on for you today. I should have told Lonnie so he could have clipped on a tie himself, but oh well. He's looking, and anyway, it doesn't really matter what we got going on. You can see my andon. Let's see if I can go the right way. My andon light over there.
Impressive.
Yeah, that's my Christmas, my Christmas decoration here. And let's bring on our friend and colleague, Stephen Lamarca. Where are you, Stephen? Hey, there you are.
Hey, guys.
Happy holidays there.
Oh, happy holidays. I got all festive today for this episode. I thought, why don't I dress up like a hipster Santa Claus in his 30s? So, I got my tracksuit on.
Boy, dude.
I look like Santa in training.
I was like, don't go too high.
Yeah, well, that and the boom mic, that's looking good. And of course, it would not be a holiday special without our good friend and colleague, Dr. Cyber Kyle from Georgia Tech. Hello, Cyber Kyle.
Happy holidays, everyone. How are you all?
Great.
Well, as we say here in Georgia, just peachy.
Steven's drinking his spiked eggnog.
It's tea. I promise it's just tea.
Disagree.
Yeah.
Just tea. Okay, I like it. So anyway, listen, we're going to keep this nice and short today, but basically what we're going to show you just a couple of things that we've made for you, and we'll put some information out in terms of getting a hold of maybe some of the G code and so forth if you wanted to make your own. But we thought we'd kind of roll it all together with both the Halloween, Thanksgiving theme, and then sort of pivot over to the whole, winter, Christmas type of thing, and so I think number one is and Kyle, we're gonna show you these things in process, but Kyle, why don't you take a peek at let's take a look at our first one. You got the pumpkin there, and talk a little bit about it.
Yeah, so in honor of Halloween,
Wow.
we're going to make about a 5-axis pumpkin. I think it's 5 if I can count that high.
This many.
5 that many?
It's 6.
Yeah, cool.
Yeah, 5-axis, right? Okay, good.
Wow.
Our students over here at Georgia Tech had a lot of fun designing and making this thing out of pure aluminum, so not too bad of a machining job. This was made on a Mazak VC 500A 5X.
Did you say aluminum?
Aluminum, out of aluminum, but a solid aluminum.
Or is it just all machined aluminum?
It is. Started from a round stock.
How long did it take to machine?
This puppy was pretty fast. It only took about, an hour and a half start to finish. The vast majority of that was this finish pass right here on the bottom. Just real small step over with a ball mill.
That's cool.
Oh, so tell us how well, and we're going to shift over to the video of how it was made, but how was it held and so forth in there?
Yeah, so we held it with a 5th-axis vise in the bottom. Good couple of dovetail cuts for preparatory stock. As we were machining it, we actually using a continuous spiral. So if you imagine holding this thing, let me see if I can get my trusty cell phone here.
Your BlackBerry? Yeah.
Holding the cell phone over, and your spindle is coming in from the top and continuously rotating the part as we're rastering down.
That's neat. Very nice.
Now, the interesting thing is the step over, right? Because it's going to move faster up here with a steeper incline at a constant layer slice than it is here at the center.
Yeah.
So you have to really watch your surface finish as you're moving down the side. And it makes it nice and shiny. It's the second shiny thing in this shot.
So what yeah. So what man, funny. So what did you use for the cam? What did you use in terms of programming?
So we actually programmed this in OpenMinds Hypermill. Awesome. The design was made in a standard CAD software, just for because we had access to it. But then the CAM program was made in Hypermill.
Awesome, very cool.
So I know Tom mentioned earlier that it was held by Tom asked and you mentioned that it was held with a 5th-axis vise. How did you part that part off?
Yeah, so we actually, I cheated a little bit. So we took a standard round stock. We actually worked on our Akuma Armroid system first. So we took the Armroid system, clamped it in a big chuck on the lathe, and then it's a it's a 4-axis mill turn system. And I put a dovetail cutter in. And imagine this round stock, right? I don't want to give too much away here, but the round stock on the backside came in and milled 2 dovetails on either side.
Okay.
Took that, held it in the Mazak, a 5-axis mill, machined everything down, and then I cheated and cut it with a bandsaw.
Okay. Fair enough.
That's still really cool. I like
Yeah,
that.
very cool. So
It was the fun part.
what we should do now is we'll transition over and let's see who's going to help you out over there. Is that Alan?
Yeah, so one of our fantastic students, his name is Alan Burrell. He's a third-year PhD student in our program here. He helped out with a lot of the CAD CAM for this part, and then another part that we're going to talk about on the additive side here in a few minutes.
Excellent. So let's transition over, and soon to be Dr. Allen's going to help us. Dr. Burrell, I guess we'll go like formal, but he's going to help us out with this and so forth. And we'll take a look at it. So let's take a look at operations.
Good morning, guys. So this is Kyle and Alan standing here to talk about the pumpkin machining. So Alan, why don't you tell us a little bit about how this Halloween pumpkin was machined?
Yes, the pumpkin was machined using just a traditional strategy that's done in a hypermill. So it was done using a ball mill, just down the surface, just like we normally would, getting the rough shape out of a stock of aluminum. And then we went in and did some of the fine details with another ball mill on the face here. And got the face kind of carved in there. That way it was nice and festive for us at over the Halloween break.
So tell us a little bit about the 5-axis machine. Normally you take a single stock and you have to refixture it for every operation. How does that play out in a part like this?
Yeah, so unlike a traditional 3-axis machine where you're just, X, Y, Z, where we have 5-axis capabilities, we're able to hold this in one location and then manipulating the different axes so we can rotate it this way or around its center here. We're able to get to different locations and configurations and be able to hold it just once instead of, maybe 5 or 3 or 4 times like we would normally have to do. So a lot of these are done perpendicular to it. Kyle, why don't you talk about how that was done?
Yeah, so one of these strategies was what's called a 5-axis surface finishing pass. So in Hypermill, we set planes tangent to each of these locations, so as the tool wrapped around, it would be perpendicular to the face at every single point. So it allowed us to get a really nice surface finish and also some great contouring edges around the face of this part. Just a wicked looking part for a great Halloween demonstration here at the AMPF. All right, back over to you, Tom.
And we're back. Now I think we've seen our subtractive one. You guys are having too much fun over there. Where, it's amazing what goes on between, video clips and things like that. Or maybe what doesn't, right? But anyways, now we're going on to, so that was your classic machining one. And we can get some of the CAD files and so forth for the pumpkin out, right? And maybe even the code. Can we get the G code out there, Kyle?
We'll give the CAD file and the CAM tool paths. But we want to let people post the G code for their own specific machine themselves. But we'll give you all the technology to actually make it happen.
Awesome. Thanks, Kyle.
Yep. So you too can make your own pumpkin for next year. But now, right, we're going to pivot over. We're going to just shift up another notch. Instead of just purely subtractive, we're going to go with a hybrid, just a hybrid demo for the winter holidays. Back to you.
Yeah, so our second part, and the credit to this one really goes to Alan too, is our IMTS Snowman.
That's beautiful.
In honor of 2024.
Very cool.
I hope the video is not reversed.
No,
it'll read.
Yeah, just to tell your audience, right? So if I do this, it's sort of it's going reverse on me, but I think it is showing up in the right direction.
So this part started with just the stock, and this is part of the hybrid process where you mix additive and subtractive machining combined in the same machine. Again, our Mazak VC500 A5X AM version of it, meaning additive manufacturing. It's a blown powder system. So we started that stock and we built up the bottom half of the snowman.
Okay.
Bottom half of thirds. Bottom thirds, math's hard. Bottom half of a snowman. Then built the second part of it, machined it down. So we're mixing that additive, subtractive.
Yeah.
We built the final part and the cap and machined the cap. Now this whole part's hollow, right? The substrate is solid, But that's it. That was our starting stock. That thing is only about 4 millimeters thick.
So similar question, Kyle. How long did it take from start to finish? How hard was the programming the cam?
Yeah, so this was a pretty challenging part, to be honest. And man, I got to give credit to Hypermill, among some of the other cam softwares that are all our friends out there. But they've done a great job making this a little bit more user friendly, and the whole industry has come along a long way. Additive is a slow process. It takes about 3.5 to 4 hours to deposit this thing. Now we're going pretty slow. We could crank up. There's other machines out there as well that have a lot more power. We're being very strategic and careful when we're printing this. But the machining, on the other hand, was pretty quick. The longest part of the machining, for that matter, is that ball mill step down, again, just because you're getting this ultra fine surface finish.
Did you have to do anything at the interfaces in terms of providing a lip, or is it just, what's some of the tricks that go to making it work?
Yeah, so let's say you're just going to print a wall, right? You're just going to make this single thin wall structure. And again, with my trusty BlackBerry, cell phone, as you're printing this thing up, it's hard to pause it.
It's tough being around little kids.
It's hard to deposit right there on the edge, right? So I've built this wall, I've machined it around, I've machined it.
Yeah.
How do I hit that edge, right? That's kind of hard if I get this lined up with a camera. So what you can actually do is you can build a little bit of a lip. Imagine a little bit of V, and I'll send some pictures we can throw up in the video to kind of document this.
That would be awesome.
Yeah. Now the cool thing is, in this case, right, I have to interchange them. I have to build that lip, machine it, build that lip, machine it. With additive turning, as it's called, you can build it right into the first path. So you can actually build that into the spiral, a variable thickness wall. So it's not like a pottery wheel, right? Well, it's exactly like a pottery wheel. It's not like a wine glass where it's a uniform thickness.
Yeah.
You are sculpting, if you will, as you come out thick, thin, thick, thin. Yeah. So you can do this at the exact same time.
Yeah, that's really cool. I love that.
This is something, I had to say what's really interesting about this is, people say, well, hey, I want to hire a machinist that has 20 years experience. Well, if you're looking at some of the additive stuff, I think it's really going to be, you say, well, I want somebody who's got 20 years experience of additive. It's just not there. Right. And so this is where, in terms of what's going on, either, here over at Georgia Tech or some of our other partners, we're here to sort of help you in terms of getting some of these things going and so forth. And it is actually pretty cool. In fact, I think what we should do now is let's go over and let's take a look at the let's go take a look at making of the snowman, right? Because it is very cool. And that's all I can say. But I do want to. We'll come back in a little bit. But let's go over to making of the snowman. And again, back to and we got Dr. Burl, or I'm sorry, almost Dr. Burl is going to be there.
That's right.
All right, very good. Well, let's go out to the shop and take a peek at things.
All right, so we're back here with Alan again at the AMPF facility out of Georgia Tech. Tell us a little bit about the snowman part that you did for the holiday season.
Yes, this snowman was inspired just to really showcase what our hybrid manufacturing capabilities are here. So if you're not familiar with hybrid, we have the ability to interleave both additive manufacturing and subtractive manufacturing within a singular machine tool volume. So you can kind of see what we've done with this snowman here. We've built it up, and then we'll build up some more and then machine it back. And one of the really cool things about this snowman is he's completely hollow, besides a couple bead widths. That way we had enough support to machine on it with. But this was done in one single fixturing. Once I put it in the machine, it never came back out. And that's really the advantages of doing a hybrid machine. Is once it's located, we can just press go and have it build up, and then machine away as we need. And then we can also go in and do a lot of the fine detailing work on the edges here that we can see. We've embedded like the Georgia Tech logo as well as some of the IMTS logo. And this was all done in OpenMind Hypermill.
So this looks like a pretty interesting load part, right? What's the strategy like as you move in all 5 axes to make a solid structure like that? How does that work out on the machine?
Yes, this is it's a toolpath that's called additive turning. So what it does is it's basically a lathe or a turning operation that's been turned into an operation that's be able to do on a 5-axis machine. So as we're rotating this around, if you can imagine my fingers in deposition here, we're rotating around and keeping normal to it. And then we're changing the orientation of the part. That way we're blowing our powder directly to the location that we want and building up layer by layer. And then as we raster over, we can change kind of the orientation and configure that however we need it to be.
Hang on, you're saying you're changing the orientation of the part, but the nozzle is staying perpendicular to the ground,
Yes.
right? So is the nozzle moving on this machine, or is the part moving underneath it?
So the part is physically moving underneath the head.
Okay.
The head is tracking it, but it is staying, the part itself is rotating down as well.
Now then, you finished your first section here. Then you have a second and third section. This one's machined, this one's printed, this one's machined. How do you deposit one on top of the other?
Yes, so whenever I go back in, as soon as this section was finished, I cut it back to the exact surface height that I knew that I needed to be at. That way, nominally we overbuild, but I get it to resurface again, and then I just press go again. It's really as simple as that, just interweaving the two processes.
And you've done some nice detail work here on Frosty's hat,
Yeah.
and then I see a GT logo, and then I think we have to shout out the IMTS 2024 logo for next year's show.
Yeah.
Awesome. What else was challenging about this part?
Yeah, so really, probably the most challenging part is the part that we don't see, which is the top, eighth of an inch here, where we're transitioning from a completely hollow surface, like I previously mentioned, to where if we can see on the top, it's actually completely solid. So that transition from hollow to solid is really a difficult one in order to make it blend and look nice with the final product.
Very nice. Well, hey, thanks for your time to chat about this today. What a cool part here out of the AMPF. And with that, we'll turn it over to you, Tom Maloney.
All right. Well, that was pretty cool. And so, Kyle, one of the things I'm wondering is, do you see any, when we've got the additive and subtractive and so forth, and then you start adding again, do you see any marking or anything like that between the two?
Yeah, you do a little bit actually. And one of the most interesting things about it is how you transition that region. Because you've got a very rough surface and a very rough process additive that's transitioning to very smooth surface, right? So first, you're trying to deposit on a smooth surface. That's hard in and of itself, right? How many times when you're woodworking you rough up the edges or metal, right, to get that bond there? So that's difficult. At the same time, you have to worry when you start machining an additive part to not take too deep of a cut right at the beginning. Now, it's a little tricky. It's kind of like preform machining with a casting. So you're always taking kind of a roughing pass. Then once you know your volume, you know your stock, then you can ramp up your feeds and speeds a little more, be a little more aggressive about it. But you want to be very careful on those first couple parts.
So Kyle, on that, you were talking about the lip. Is that something that you do on the CAD? You actually design that into the CAD structure, and then it's imported into your cam, and you're doing the tool paths there, or is it you take in the CAD? You're actually imposing those constraints through the toolpath generation? How do you?
You're actually doing it on both. That's a really, really interesting question, right? Because your CAD model drives your CAM tool paths, but your CAM tool paths kind of drive your CAD model. So it's this back and forth. So we actually take the base model. We take the base model as is, no changes, and we import it into our CAM software. And then we have a choice. We can either draw in the extra splines and lines and segment this part up and make individual solid bodies, or in the particular case of Hypermill, of surface-driven geometry. Or we can take it back into the CAD software and make it a solid model and then iterate back and forth. So it just depends on the part. Sometimes it's better to do it just in the CAM software itself. Yeah. Sometimes you really need you really need to go back to the original model. So it just depends. But yes, you can do it on either side.
Is there any work going on the CAM side where that's just a part of the CAM you're going to be switching, so you need to have these features that the CAM does it automatically? It's kind of like support. When you're doing 3D printing, your support generation is automatic. Yeah. Is there anything similar to that going on the CAM side?
So at this point in time, in particular in Hypermill, and I don't want to speak too much for them. I know they're working on some of the stuff like that. Yeah. And so that's maybe in one of their future releases. But I'd like to highlight our other friends here at Autodesk for a second. Yeah. Al Whitma and his team. at Autodesk on the CAM side. So they've generated some things called manufacturing models. And what it allows you to do is actually to take a solid body or whatever you made in Fusion 360 and have kind of a fork of it, right? Have it that same tree, that parent structure, have one version this way and one version this way.
Yeah.
And that manufacturing model has some information and some geometry that the space model doesn't.
Yeah.
It allows you to modify this. It's the same thing. It's just making it a little bit easier to use, and they're getting there. So I'd really like to call out them and as one of the leading edges as well.
That's cool.
Yeah, I'm thinking, maybe one of the things is going to come down in terms of our podcast is maybe we need to bring up a podcast or two about some of the tools that we're using, some of the software. I know everybody loves the big machine and sort of melting of the metal and so forth, but I'll tell you, I mean, that's just sort of part of it. It's the know-how, it's the software tools that allow you to do things, and so forth. And it is interesting. And again, I just wanted to really highlight, but make sure everybody out there understands what Kyle's talking about. If you've got a 3D printer with plastic, I think everybody knows you want to go about, you can't go more than 45 degrees because I print and it just kind of plops down. But I can kind of go to 45 degrees and build this thing up. Well, you've seen kind of molten plastic and it kind of oozes out, right? And it's pretty viscous. If you take a look at molten metal, right? In this particular case, steel, Kyle, we're doing, what is it, 316?
410. 410 steel.
Okay, thank you. So 410, when molten metal comes out, you can't do it at 45 degrees. It'll just drop right down on your table. So you're sort of limited there. Now, this is where, and again, you saw this in terms of the 5-axis, you could do all sorts of interesting things. And you saw the turning. Again, people think of 3D printing like this, but you saw the additive turning. So it's just a completely different way to think about things, and not just geometry, but like Kyle was saying, you got to put that little lip on there, because if I print out this wall and then I machine it back and now I want to go print the next wall out, right? Well, I can't do that. I've got to leave that little lip there. So I machine, but I leave a little lip so I can continue to add there. So,
I'm super excited about these hybrid systems because they solve, now you're beyond just the 2.5D you have with a typical powder bed or a typical additive system.
Yeah.
You actually now can get net shape, and you can have multi-axis. It solves a lot of the support problems. Really, really cool. It's great work you're doing, Kyle. Really love it.
Let's take this out of just the holiday special for a second. When we're talking about these big parts and these big castings, we were at one of our partner institutions and company friends a couple days ago, and they're making these large casings, right? They have to add in so much material radially, and we're talking 5-6 feet diameter, just to machine a little boss away, right? All of that material gets removed just for that little tiny boss, and this is where it gets interesting with hybrid technologies.
Yeah, absolutely.
Yeah.
Absolutely. Yeah. Instead of making it over and machining it back, make it to the minimum that you need and then add the features on and machine.
Yeah. Right.
Save a lot of money and time.
Oh, money, time. Think of the tooling, all the chips. And I mean, these guys, they were making huge parts. Yeah. And they just had dump truck loads of chips that they just sort of sending out. It was amazing. But so I think, lots of really good stuff here going on, lots of ways to go. And lots of opportunity. By the way, the other cool thing about the hybrid machine is if you want to get into additive, you could buy the hybrid machine, but if you're a machine shop, you can still use it as a machine tool. So you don't have additive work, you can still do your subtractive work. And there are lots of other crazy things that we're thinking about with this in terms of how to really utilize that. And that's coming down the road, I am sure. Thinking at the
Kyle, on that company, are you giving them the model and saying, I want a big snowman? I mean, make me a big snowman, 12 feet tall, 10
I wish. They work in Thai 6.4, and man, that'd be fun.
Snowman.
Yeah. I think it'll still be cheaper to get the little, the nylon blow up one, than
And so it's a real quick story. When I first was dating my wife, we were driving up to see my parents, and as we're driving, I'm telling we're going, it's the winter season, we're seeing all the lights and stuff, and I start asking her, well, how do you like colored lights? Oh no, she's a Southern girl, she likes white lights. I was like, what about like the big snowman in the front yard? Oh, that's so tacky. And we pull up into my parents' yard, and she goes, you better not say one thing because there's the blinking colored lights, the snowman. It's like, it's awesome.
Amazing.
She still hadn't forgiven me because I walked in. I said, "Hey, Mom, ask Beth what she thinks of your decoration."
Well, there you go. And boys and girls out there, that's what not to do with your spouse. All right.
Marriage advisor.
Wow. And that's advice directly from Dr. Love. Okay. All right. Well, hey, listen. Oh, by the way, before we go, we have a special treat for you. So the person behind the scenes who you'd never see or hear from and so forth is our friend Ramia. Ramia, can you pop on and say hi to everybody? We wanted to thank you especially for taking such good care of us.
Hi, guys. Thanks for having me. Always great. Always great.
Yeah, thank you for all you do, Ramia. You make us look good, and that's a full-time job.
Oh God, yeah, it is
True.
not easy to make us look good. I got to tell you. Well, Kyle's looking pretty good, I got to say. But the other three guys, man, So,
Yeah.
well, although I am, got my fashion statement on here today. All right. So, with that, we're gonna let everybody go. And again, we'll follow up on some of these because I think these set the stage for some interesting technical talks for next year. And of course, what is next year? Right on, our cyber snowman there, 2024, IMTS. Thank you. So and by the way, make sure you come to IMTS because Tom and Lonnie chat going to be live on IMTS. Looking forward to it.
Happy
All right,
holidays, everybody.
Well, listen, have a nice set of holidays. Stay safe, and we'll see you in January.